So far, I have talked about S3 node and its corresponding storage in the high-level S3 architecture. So what happens is that there can be hundreds of thousands of nodes and there would be disks associated with those nodes. Again, not only one disk, there can be multiple disks attached to a single node. And you know by now that that particular node would execute or run multiple services that cater to different features in S3. Now in this particular section, I'll start with something called S3 storage class. Now when I talk about storage class, what does that mean? As you can see, I have highlighted the storage part here. So we'll be talking about the disks and its different types that are available in S3. So these are also managed by certain storage services in S3. It's not that we have only disks associated with this particular feature. There are programs and services running for storage class also. What is a storage class? It provides different storage types, access latency, and availability based on usage. Meaning that we can decide the type of storage based on the usage of our workload, and that particular type of storage would decide the latency and also availability. And as you can see, I have highlighted that the storage class is mentioned at object level. So that's why I'm discussing it in the object part, not in the bucket part. So in the bucket properties, we did not see any storage class at all. Now I'll show you where do you mention storage class in the object. So while uploading an object, either using the console or using CLI, or let's say AWS SDK, etc., we can mention the storage class. So for example, I have this bucket, 3IAM S3 bucket, and I have deleted all the files. And now let me go ahead and upload a single file. So I'm uploading orders underscore 2 underscore 10.csv. Now while uploading, so far what I have done, I have just shown you to click upload and the object or the file would be uploaded. But there are a lot of other details that you can mention while uploading the object. So here we have destination details. So basically this is the bucket, encryption type and object lock, which you have already seen at bucket level. And then we have permissions. I'll talk about permissions in the security part. And here we have properties. Now in the properties, as you can see, I can mention the storage class. So I have different storage classes, standard, intelligent tiering, etc., etc. And I can mention which storage class I want to upload this object to. So this is what I'm going to discuss now, these various storage classes, the purposes of those storage classes, and how different storage classes gives us the availability and scalability or latency that we need. So I'll cancel it right now. As you can see, while uploading, I can mention the storage class. And the same thing can be done while uploading the file using AWS CLI or command line interface. So to start with, there is S3 standard storage class, and it is the default storage class provided by S3. Now all of these storage classes use SSDs behind the scenes. Now S3 standard, what is this S3 standard? So this is basically a highly durable, highly available and high performant for frequently accessed data. Now remember this, the storage class is meant for frequently accessed data. And this point is important, that it is needed for frequently accessed data. So if you have files or objects which you will be accessing pretty often, it's better to store them in S3 standard storage class, because it gives durability and availability also. We'll talk about availability shortly. And it provides low latency and high throughput, meaning that you can send a lot of requests to S3 storage and you can upload a lot of files parallelly, and S3 standard storage class would be able to handle it while providing low latent response times, meaning that it will not take too much time to upload those files if you use standard storage class. Of course, if the file size is pretty big, then it would take certain amount of time, but the time taken would be again lesser than other storage classes. And by default, it is stored in at least 3 different ACs. And that's where we get the durability and availability from. So if we have one node and one storage here, it will be stored in at least 2 more nodes in different ACs. And let's say this particular node is in US East 1A, this would be in US East 1B and this would be in US East 1C. So you get high durability and availability out of the box. This is non-configurable. It is given to us by default. And the use case is analytics. So it is typically used for analytics, reporting, and other workloads. So this is the first storage class, and it is the default one because of the performance, availability, and durability. We have another storage class which gives better performance, but that storage class compromises on availability. The next one that I want to talk about is standard IA, or standard infrequent access. So it is similar to S3 standard storage class. It is highly available, high throughput, low latent, but for less frequently accessed data. So if you know that your data would be accessed once or twice a month, then it's better to store it in standard infrequent access. And it gives the similar durability, availability, and throughput, and also responsiveness as that of standard storage class, because it is stored in at least 3 different AZs. And typical use cases are for disaster recoveries, backup, higher duration for compliance, and maybe log storage. These are some of the use cases. Now, of course, there might be a question that why do I have to use standard infrequent access rather than S3 standard if the durability, throughput, performance, availability, everything is same? The reason is cost actually, which I'll talk at the end of the storage class topic. As I told you that in the previous slide, that we have two different storage classes, S3 standard and standard infrequent access, which gives you high availability and high durability and high good performance also. But if you need faster performance, we can use something called S3 Express One Zone, and it is high performance single AZ. So the data that we upload in S3 Express One Zone storage class, that is stored in a single AZ, and it is typically meant for frequently accessed data where we need very low latent access, like single digit millisecond data access, and it is almost 10 times faster than the standard storage class. If you need very fast access, then you might want to use Express One Zone storage class, where you can compromise on the durability. And it is mostly suitable for storing small sized objects. If you have pretty large objects like few hundred gigabytes or so, you should use S3 standard rather than Express One Zone. And typical use cases are analytics, reporting, dashboarding, etc., and machine learning also. So if you have machine learning models which will read data from S3 and do some pre-processing, then it's better to use S3 Express One Zone, which gives you very high performance, low latent experience. Now for S3 Express One Zone, we cannot create a bucket directly. We have to create something called directory, which I'll show you later on. We have a separate topic for S3 Express One Zone, and we'll discuss that in future slides. Now, similar to standard infrequent access, we have one zone infrequent access also. Again, this is same performance and latency of S3 standard, so not Express One Zone, and it is meant for less frequently accessed data, and also it is stored in single AZ. So if you are not worried about high availability, then you can use S3 One Zone infrequent access, wherein the data would be stored in a single availability zone and will give the same performance and latency as that of S3 standard. So far, the storage classes that I have talked about, those are mainly used to handle data which are accessed very frequently or less frequently. By less frequent, I mean maybe once a month, twice a month, once a week, etc. Then, apart from less frequent access, S3 also provides a storage class for archival data, wherein we can archive the data which you know would be accessed maybe once a year or once in 2 years or maybe twice or thrice a year, not more than that. So that's where we have Glacier Instant Retrieval storage class. So in this storage class, what would happen is that we can use it to archive data, wherein we have to retrieve the records maybe once per quarter or once in a year or maybe once or twice half yearly, etc., etc. Basically, the retrieval requirement is very less, but still we need to archive the data for compliance and other reasons or data governance reasons. But S3 Glacier instant retrieval would give you immediate retrieval, meaning if you want to access data, the records would be read immediately. So it gives you millisecond access latency as that of standard and standard infrequent access storage classes. But it is used mainly for archiving data, and typically it is used for medical records, media contents, documents, etc. And let's say we are using something like Facebook, Instagram, and we are storing data there. There are a lot of photos which get uploaded. So what you see is that the photos which are uploaded recently can be accessed pretty soon, but the photos which are pretty old are automatically uploaded to cloud, and it takes some amount of time to retrieve. So that's where Glacier instant retrieval might play a very important role, because we want to store the records, we want to store the data, we do not want to delete the data, but we want to pay lesser price. So that's where Glacier instant retrieval comes into picture. And we can use the API to upload directly or using lifecycle policies to Glacier instant retrieval. Then you have Glacier flexible retrieval. This is a little different than instant retrieval. So the access requirement is similar to that of Glacier instant retrieval, wherein we want to read the data maybe once or twice a year, but the retrieval might take anywhere from minutes to hours. So that's where the difference lies between instant retrieval and flexible retrieval. Both are archival storage. For instant retrieval, the access is within in milliseconds. Of course, it would take its own time depending on how much data is downloaded. So millisecond access is basically block level access. But in case of flexible retrieval, those access would also take certain amount of time. And as you might have guessed, that it is used for less frequently accessed data and typically used for backup and DR. We have one more storage class for the archival data, that is Glacier Deep Archive. So what happens here, this is mainly for long-term preservation for compliance and data governance reasons. Let's say we want to store data for 5 years or 10 years or 15 years, but we do not want to pay too much of price. So that's where S3 Glacier Deep Archive would be helpful. And typically it is used in financial organizations, insurance organizations, and healthcare organizations. And the retrieval time is pretty high. There's no guarantee. It says that the retrieval time should be within 12 hours. So it does not matter what the size of your file is. It might take anywhere from few hours to 12 hours to retrieve that particular data or file. So these are the different storage classes that we can select. We see that, okay, this is how the access path is, or this is how the access pattern is. And based on the workload, we can decide which storage class we should use for a particular object. And we can change the storage class also. So maybe we upload it in standard storage class, then we can move it to other storage classes, either manually or using something called lifecycle policies or lifecycle rules. But let's say you do not want to do all those things. You do not want any manual intervention, or you do not want to provide any lifecycle rules, and also you do not know how the access would be. Maybe some files should be accessed frequently, even though you think that those are meant for archival data. So how do you handle those kind of scenarios? So that's why S3 provides something called intelligent tiering storage class. So in this storage class, what happens is that S3 automatically moves objects across storage classes based on the access frequency. So if you do not know what access frequency would be for your objects, then you can use intelligent tiering, and behind the scenes S3 would look at the access patterns, access frequency, etc., and then it will move the file across various storage classes. By storage class, I mean all the storage classes that I have discussed so far. Glacier Deep Archive can be thought of as a replacement for magnetic tape archives. Now the question is, why do we have so many different storage classes and storage types? For example, S3 standard and standard infrequent access gives the same availability, same durability, and same performance. So why do we have two different storage classes? Why not only one storage class like standard? Same is the case with Glacier also, or single zone also. So the main reason is pricing. What happens is that the pricing of these storage classes are very different. And the pricing that I'm going to show you here is very high level. So I'll go into the details of pricing when I talk about S3 pricing in later videos. For standard storage class, we'll have to pay $0.023 per GB per month. And for standard infrequent access, we'll have to pay $0.0125 per GB per month. So you can see the price difference. So standard is almost double as that of standard infrequent access. Same is the case with Express One Zone and One Zone IA. Express One Zone is $0.16 per GB per month, and One Zone IA is $0.01 per GB per month. Express One Zone is pretty costly, and there's a reason, because you get millisecond access latency. Glacier Instant Retrieval is $0.004 per GB per month. Glacier Flexible Retrieval is $0.0036 per GB per month. And as you can see, Deep Archive has the lowest cost with $0.00099 per GB per month. So that's why you want to use different storage classes and storage types. So if you need frequently accessed data, which is highly available and durable, then you can go ahead and use standard storage class. If it is highly durable, highly available data, but you don't access it frequently, then you can use standard infrequent access. And One Zone is basically for the files or workloads where you need very fast access. Now, this is basically from AWS documentation. So on the left hand side, it tells you about the different storage class and what is it is designed for. You can go through it, but I have actually got the slide to tell you about the durability and availability numbers. For S3 standard, it gives you 11 nines of durability and 4 nines of availability. But standard infrequent access gives you 11 nines of durability, but the availability is 99.9 only. It's 3 nines, not 4 nines. So that's why S3 standard is costlier than standard IA, even though both are highly available, durable, and performant. The availability is a little less for standard IA. So intelligent tiering storage class gives you 11 nines of durability and 3 nines of availability, which is 99.9. And One Zone IA gives the least availability, which is 99.5%. And durability is same, 11 nines of durability. And S3 Express One Zone, similar durability, but availability is higher than S3 One Zone IA, S3 Intelligent Tiering, and Standard IA, which is 99.95. Now, the thing is that if you see the availability zones, S3 standard would keep the data in at least 3 AZs, same as a standard IA and intelligent tiering. But One Zone IA and One Zone Express will store the data in one availability zone. So sorry, this is One Zone IA, this is Express. So One Zone IA has the least availability, and Express One Zone has availability a little higher than One Zone IA. For all the Glacier storage classes, we get 11 nines of durability. For instant retrieval, we get 3 nines of availability, as it is stored in at least 3 different AZs. For flexible retrieval, we get 4 nines of availability after we restore the objects from flexible retrieval to some of the storage classes. So Glacier Instant Retrieval also gives you 11 nines of durability and 4 nines of availability after the object is restored. What is meant by that is, if you have your file or object in Glacier Flexible Retrieval storage class, we'll have to move it to any other storage classes from where you can access the record or access the object rather. So it can be any S3 standard, standard IA, One Zone Express, or instant retrieval also, because you cannot read the files directly from flexible retrieval storage class, and it is also stored in at least 3 different AZs. Same is the case with Deep Archive, gives you 11 nines of durability and 4 nines of availability, as it is stored in at least 3 different AZs. And this 4 nines of availability is after we restore the objects to any other storage classes. And that's about different storage classes. And I have also shown you how you can actually mention the storage class while uploading the objects. Typically, you'll be using storage class with lifecycle policies or lifecycle rules. In most of the cases, you might be using intelligent storage tier also. So there's not much hands-on to be shown for this storage class. Although I'll show you S3 Express One Zone because that's a little different than any other storage classes. S3 also provides something called conditional upload. Now, what is this conditional upload? If we upload object with the same name, what happens to that object in the bucket? It gets overwritten. And to avoid that accidental upload, accidental delete, etc., we use versioning. So delete is something that we cannot actually control too much, but you can control the upload. And that's where conditional upload helps. By default, a file is overwritten if the same key is present in a bucket, but it can be avoided by conditional upload. So what it does, it checks whether the file is available or not. If the file is available, then S3 will not upload the file again. And it can be achieved only using API or CLI. We do not have any option in the console to do a conditional upload. And one more thing to note is that the CLI version should be at least 2.19.1. And this is the command. So as you can see, we are using S3 API command and then the put object. We mention the bucket name followed by the key name, and we mentioned something called if none match. So this is the main keyword. So if you mention if none match followed by asterisk, then the same object will not be uploaded if it is already there. Now one more thing, if you are using a version which is less than 2.19, then you might get error that if none match is not a valid option in the command line. So if you get that option, if you get that error message, make sure to upgrade the CLI version. Now the first thing that I want to show you is that in this 3IAM S3 bucket and in the retail folder, I already have customers underscore 2.csv and orders underscore 2 underscore 10.csv. So what I'm going to do is that I'm going to upload the same object using CLI from the EC2 instance. And when I do that, I should get an error. Now let me open the EC2 console, and there's one more thing that I have to tell you about EC2 instance profile. So this is something related to IAM or Identity and Access Management. So if you don't understand it, please go ahead and look at the IAM video and then come back to this particular section again. What I'm doing is that if go to actions and go to security and click on modify IAM role. So I have already an IAM role associated with the EC2 instance, and this IAM role has S3 full access, meaning that if I open the IAM console and if I look at this AWS data engineering EC2 S3 full access IAM role, so I'll have to go to role and type AWS data engineering. So this is the role, and as you can see, I have associated S3 full access to this role, and the role is associated with the EC2 instance. Make sure it is done. If you don't understand, please go ahead and look at the IAM video and come back to this hands-on again. All right, so now what I'll do is that I will log into this EC2 instance, and I'm inside of the EC2 instance. As you can see, I have this file orders underscore 2 underscore 10.csv in the EC2 instance itself, and I'll use the S3 API command line or S3 CLI rather to upload this file in the S3 bucket, 3IAM S3 bucket, and in the folder retail. So this is the command is AWS S3 API followed by put object. Then I'm providing the name of the bucket, which is 3IAM S3 bucket, followed by the key. Now remember, in the key I'm mentioning the folder because folder is part of key, not bucket. So if I mention 3IAM S3 bucket slash retail, it will give me error that there's no bucket as such. So the folder name is also part of the key. And here I'm mentioning if none match. Now if I execute this, I'm getting this error, unknown options if none match. So basically the reason is that if I type AWS S3, sorry, AWS version, as you can see, the version is 1.18. So I'll have to go to 2.19. So I'll have to upgrade this CLI version. Now to upgrade, just type upgrade AWS CLI, and it will give you a documentation installing or updating the latest version of AWS CLI. And in Linux, what you have to do is we'll have to first remove AWS CLI. So copy this. So there's no AWS CLI anymore. If I type AWS // version, it will say no such file or directory. So I have removed it. I have downloaded, I'm unzipping the file. So this is the file that I have unzipped, AWS. And then I'll have to run the command sudo AWS install. I have not put the commands in the command sheet because you can find it pretty easily in Google. So now if I type AWS -- version, so as you can see, the version is 222. And now if I run this command, it should not give me any error, but I'll have to add user local bin AWS in front of it. So now it is running. So as it says, an error occurred. This is a different error. It says precondition failed when calling the put object operation. So at least one of the preconditions failed, which is basically if none match. So as you can see that the object or the file was not uploaded because it already exists in the bucket and the folder that we have mentioned.